Hello everyone, welcome back to the another session in design and analysis of algorithms. This video will be going to talk about Knapsack problem, how to solve Knapsack problem using greedy method. So this topic you will find in unit 2 topic 6. Let us try to apply the greedy method to solve the knapsack problem. So basically knapsack is what? You can say knapsack as a bag or as a container. Now, so generally what we will do with the bag, we'll place the items inside of the bag, right? So if I have a bag, something like this, or a container, what I'll do with this bag, if I have some items of I1 to some IN, I will place these items into the bag. So now, each object will be having some weight Wi, and the knapsack itself, it is having some capacity to keep the item safely. That is what the capacity, which is m. Now if I wanted to place all these items inside of the bag, I cannot place all the items keeping the constraint, which is bag capacity always should be less than or equal to m with the placing of the objects. Now if my objects are something like, if I'm taking the xi is my objects. Now always the weight of these objects should be less than or equal to m. M is what? Capacity of the knapsack, where I lies in between 1 to n. N is what? Total number of your inputs. So your bag should not exceed the capacity of this your bag should not go beyond of the capacity. So this is what the constraint. Subject to the constraint, objective is what? The main objective is what? We will be looking for maximize the profit. So whichever items you are placing inside, see that the items will give you maximum profit. That means pi xi should be maximum. When you find some feasible solutions, all feasible solutions will give you some profit at the end, right? Among all these profits, some solution profit will hit to the maximum. That is what the objective of the knapsack problem. So all the solutions are feasible solution. Whichever solution will give you the maximum, that is what? Optimum solution. Now, so knapsack problem is basically what? Maximization problem. For a maximization problem, we can apply greedy method. Okay. Now the very important point over here is, while you are placing the items inside of the bag, few of the items may be placed not fully but fractionally. That means there are some items. This algorithm is applicable for only the items which are divisible, not the items which cannot be divided, because to satisfy the constraint, we'll place all the items. Most of the times we'll place fractional items to satisfy this constraint. Now we'll take some example and we'll talk about it. Before we'll take an example, let's understand what is the greedy knapsack algorithm. So here the greedy knapsack algorithm is what? We will be taking some items. That means here m comma n gives you two parameters, that m is what? Your capacity of the bag, and n is what? The total number of items, right? Now so I'm taking some array which is p1 to n is an array, and w1 to n is the another array, which contains profits and weights respectively of the n objects ordered such that pi by wi greater than or equal to pi plus 1 by wi plus 1. This is what most important thing. M is the knapsack size and x is or the objects which are going to X is what? The solution vector, where I'm going to include the subset of the solutions into an array. Now, for I equal to 1, x of I is equal to 0.0. That means what? It is a solution vector. So basically solution is what? Empty before we starting the procedure. Now, I'm assigning the back capacity to the variable which is u. Now I'm going for each element to find out whether it is feasible or not. When it will be a feasible, each of the item of our items that n is our inputs. Now x n1 n2 n3. Now the first item weight should be always greater than your u. Then it will be break. That means what? If the bag capacity is 10, if the first item is itself it is 11, then there is no need of placing this item as it is w of I greater than u, then you will be coming out of it. That means you will be going to increase the index of I and you will place the second item. Now for second item also we'll check whether the weight of that particular item is greater than the bag capacity. If it is greater than the bag capacity, then there is no use of placing the item into the bag. If it is not, then what we will do is we will place that item inside of the bag and we will cut or we will ignore that weight whatever it is placed. Let us see that I have two items x1 and x2. The weight of x1 is 5, the weight of x2 is some 2. My bag capacity is what? 6. Okay, now what I will do is we will be placing the first item which is x1. Now this is what the total capacity is what? 6, but I have utilized the 5 kg of bag, right? So that means u minus wi. What is u? Your bag capacity which is m. Your bag capacity which is m, that is 6. 6 minus wi. The first item weight is what? 5. So leftover item capacity is what? 1. Now your bag is still having the place to store 1 kg item. As I have a second item which is 2 kg, I'll take only half of the weight. That means 1 by 2 weight I'll place here. So this is what the greedy knapsack algorithm. Now we'll take some example. So this is the example. This example I took from the previous question paper of Osmania University. Now according to this example, total items are 7, bag capacity is 15. Bag capacity is 15. Now let's see, to place the first item, when you wanted to place the item, there are two questions in our mind, that to place the minimum weight so that I can place more items, or to place the maximum profit so that I'll get more profit with the item. So to rule out this confusion, what we will do is we will calculate the profit for each weight. We will calculate the profit for each weight. So we will find P by W value to place the item inside of the bag. Now find out P by W values for all this. So 10 by 2 is what? 5. 5 by 3 is what? 1.3. 15 by 5 is what? 3. 7 by 7 1. 6 by 1 6. 18 by 4 approximate 4.5. 3 by 1 3. So this is what P by W ratio. Now after you found this P by W, what you have to do is whichever ratio of P by W is more, that item will get placed inside of the bag. Now so let us take this, that this 5 is what? X1. X2 is 1.3. Like so 6 is what? X5. Now place X5 inside of the bag. As far as algorithm is considered, for every item place you have to deduct this weight from the bag capacity, right? Now what is the first is what? I have placed X5 item in the bag. Now X5 weight is what? X5 weight is 1. Total bag capacity U is equal to U minus Wi. U is what? U is M. M is what? As far as the example is concerned, U is equal to 15. Now 15 minus W of I. I is what? Your item what is placed inside of the bag. So Wi means what? W5. W5 is what? The weight is 1. 15 minus 1 is what? 14. Now your bag capacity after placing x5, bag capacity is 14 kgs. Now, so which item is having the maximum P by W value? After this 6 you found it is 5. Now what is 5? X1 object. Now place X1 object. Now I am placing X1 object. So by the time I place X1 object inside of the knapsack, bag weight is what? 14. U value is 14 minus Wi. Wi is what? Wi. I is what? 1. X1 weight is what? X1 weight is 2. 14 minus 2 is equal to 12. Now, X1 is also placed. By the time I place the X1, the weight is what? After I place X1, the weight of the bag is 12. Now, so which item I can place? So which is having more P by W ratio, and that is of 4.5. Now let's see. 4.5 is what? X6. X6 I am going to place in the container X6. So when I wanted to place X6, U is equal to actual value is updated with 12, right? 12 minus X6 weight. X6 is this and the weight is 4. 12 minus 4 which is 8. Okay. Now, so your capacity of the bag is updated to 8. So still you can place 8 kgs worth items. So now find out what is the next maximum of P by W. You have 3 figures over here. One among it is I am choosing this 3. Okay. Now, so this 3 is what? It is X3. Now X3, U value is 8. The weight of the X3 is what? 5. 8 minus 5 which is 3. X3 I am placing inside the bag. So after I place X3, still how many kgs I can utilize? 3 kgs. So 3 kgs. Again you can place. Now look at the item what you can place. So the greater value is what? Again this 3, right? So this 3. I think I am doing right only. 12 minus 4, 8. We will get 8. So after that 8 minus 5 will get 3. Now 3 minus next item is what? If I place the next item X7, 3 minus the weight is what? 1. Yes, I am doing right only. 3 minus 1, that means X7, right? Now I am placing X7. So place X7. U value is what? U minus Wi. Your U is what? 3, updated to 3. Weight of this is what? 1. 3 minus 1, now 2. So after you place X7, still you have a place in the bag of 2 kgs you can place. Now, which items you placed? And X1 is done, X3 is done, X5 is done, X6, X7 are done. Now there are 2 items left, which is 1.31. So among these 2, which is having highest value? 1.3 is having highest value. So now 1.3 weight is what? 3. But you have available weight is what? 2 kg. Now your bag, if you keep the entire item of X2, your bag will be not useful, correct? Because it will get tear as you are increasing the bag capacity weightage. So what we will do is we'll take fractional part. What is the fractional part we'll take? We'll take only, you have a weight of 3, but we'll take only 2 by 3 fraction from X2 object. That means X2 also will place, but not fully, but 2 by 3. Okay. So that means if you place x2 object I am placing, u minus 2 minus 2 is 0. That means we were used complete capacity of the bag. That means our bag capacity, which is xi wi less than or equal to m. Let's see, is really xi wi is less than or equal to m. Xi values are what I have placed. Xi will give you the placed values which are into the container. What items we placed inside of the bag? x5 we placed, x1 we placed, x6 and x3, x7, finally x2 we placed. These are what items. Now do this xiwi. Now it is what sum of xiwi less than or equal to m, where I is lies in between 0 to 1, 1 to n. I is lies in between 1 to n. Now x1 is placed. Yes, so we will go with the thing 1 into 2. Object is 1 we placed, and with the weight of 2, the plus. x2 we placed not fully but 2 by 3. So we'll take 2 by 3 into the weight 3, and we placed x3. x3 also we placed fully 1 into 5. x4 we did not placed 0 into 7. x5 we placed 1 into 1 and 1 into 4 plus 1 into 1. Now 1 into 2 is 2. 3 get cancelled 2. 1 into 5 plus something into 0 plus 1 plus 4 plus 1. Finally 2 plus 2 4 plus 5 9 plus 10 5. Total is 15. So wxiwi, summation of xiwi less than or equal to m is satisfied. So we reach the constraint of maximization. Now let's see, in the definition part we were seeing about this, right? That the profit PIXI should be always maximum. Then this is what your optimum solution. Let's see what is PIXI. PIXI is what? 1 into 10 plus 2 by 3 into profit of x2 item plus 1 into 15, 0 into 7 plus 1 into 6 plus 1 into 18 plus 1 into 3. So finally you'll get the answer, which is 55.3. So this is what the maximum profit and the bag capacity. So the constraint is what? Wi, sum of xi wi less than or equal to m is the constraint, and which we got from this problem, and the objective is what it is? Maximization, that is xi pi should be maximum. So this is what knapsack problem using greedy method. It is also called as fractional knapsack problem. Thank you all.